Although there are many good applications for a series circuit, like the one demonstrated on the left, there are also some limitations. And so a parallel circuit, as demonstrated on the right, would be much more useful. The equations in a parallel circuit are going to be different than those in a series circuit. For example, in a parallel circuit, current equation is the sum of all the current. So I1 plus I2 plus I3 equals I total. In a parallel circuit, the voltage is equal throughout. And then we get to this heavy bad boy. The total resistance equals the inverse of the sum of each individual resistance. All right, that sounds like a lot, but bear with me and let's figure out why. The main difference between the series and parallel circuit is that in a parallel circuit, the electrons have a choice on which path they want to go. As you watch the white circle go around this parallel circuit, you'll notice that every time it reaches a red dot, it splits. This is symbolizing that a portion of the electrons are going to continue on one path and the other half are going to continue on a different path. Thus, only a fraction of the electrons are going to flow through any one resistor. Remember that total current equals the sum of all currents. On the far left-hand side, we're starting with 14 amps. Then the electrons go into three different ways: top, middle, and bottom. The current on each of these lines is different because the resistors are different. However, they still add up to 14. Then, once all three lines connect back up, it equals 14 amps. A question I could ask you on a quiz or exam could look something like this. I could ask you, what is the total current? I would highly suggest drawing and using this table on your quiz or exam to figure out the solution. So let's walk through this together. First, you know voltage total, so we can put that in the voltage total spot. Then, as we learned earlier, in a parallel circuit, the total voltage is equal throughout. So we can put those values in each of the voltage boxes. Next, we can put the resistor values in their appropriate box. From this point, you have one of two options. You can either calculate resistance total, or you can calculate the current as it passes through each separate resistor. Let's calculate the current as it passes through each separate resistor. Using our Ohm's law triangle, we can get this value. So starting with the column R1, let's plug in those values into the triangle so we can get the current. If we divide 9 into 90, we get 0.1 amps. So in the R1 column, voltage is going to be 9 volts, current is 0.1 amps, and the resistance is 90 ohms. In the R2 column, we divide 9 and 45 and get 0.2 amps. And in the R3 column, 9 divided by 180 is 0.05 amps. Using the equation that we learned earlier, total current is the sum of all currents, so we need to add 0.1, 0.2, and 0.05 to get the total current, which is 0.35 amps. Now we know the total voltage and the total current. All we need is to use Ohm's triangle to get resistance total. We plug our values into Ohm's law triangle, 9 divided by 0.35, and we get a total resistance of 25.7 ohms. Now remember earlier when I said you had one of two options? You could either calculate total resistance or you could calculate the current as it passes through each separate resistor. Let me show you what it would look like if you decided to take the first option, which was to calculate total resistance. So if we want to find resistance total at this point, we would have to use this equation. So if we're going to use this equation, let's plug in our values for each resistor. So we get 1 over 90 plus 1 over 45 plus 1 over 80. Next, we need to find a common denominator, which is 180. 90 goes into 180 two times, so it's 2 over 180. 45 goes into 184 times, so it's 4 over 180. And then 180 goes into itself one time, so it's 1 over 180. Add those values up, and we then get 7 over 180. However, we still have that 1 on the other side, so we need to divide each side by 1. So it's going to be RT equals 1 divided by 7 divided by 180. And if we do that long math, we will get to RT equals 25.7 ohms. Fear not. I know this is really overwhelming and it sounds like a lot, and I know none of us are electrical engineers, but you'll get it. Just memorize these equations that go along with the parallel circuit, as well as the equations that go along with the series circuit, and you'll be fine.